Welcome to my Halloween special. Glad you're here. This is YouTube Live. I am Bret, and today I'm going to talk about spooky security. Really just security, but I had to throw in a Halloween word, so spooky. Spooky. So glad you're here. This is basically going to be me talking for an hour, taking your questions about Docker security, and going through basically my top 10. It's the things that I look to when I'm implementing a Docker project, when I'm working with a team, and it's actually not really complicated stuff. I don't really recommend to most people the super advanced stuff that takes an entire project to implement, just because most projects, when they're starting off with containers, don't have that kind of time or resources. So I want to focus on the easy stuff, right? The things that you could probably implement in less than a day, or your team could at least understand and test in less than a day. And that's really what I like to do. I like to give the easy stuff and really the stuff that's a big win, right? The things that really will improve security in some measurable way instead of maybe some theoretical thing that in theory could, I'm not about the theory stuff. I'm more about, hey, we've seen these kind of problems. Let's eliminate those problems with best practices. So this isn't me just pulling the common things like use better images and don't store passwords in environment variables. Like, we probably all know that stuff. It's more of the things that maybe you won't see in the documentation right away, or you won't see in a common blog article about security. So let's get to it. So this is the hour that you get to ask questions, and let's keep them security focused. They can be about anything container security related. I may not have all the answers, but you start piling in the questions. And I'm going to go through my list, and we can take questions as we go. We can save them all for the end. That's really up to you. And you being in chat, you control the questions, right? I get to control the answers if I have them. So I have a list, and it's at a URL. Let's see. And I actually made a friendly URL for this. I will type this into chat. Bret.show/security first. All right, so I type that in. That will take you to my GitHub AMA, essentially. And my AMA is where you can ask questions like you ask in this show, but you get to ask them offline. And whenever I can get to them, I get to them, which isn't always, it's maybe once every couple of weeks, that kind of thing. And that's just a shortcut. That Bret.show/security first is a shortcut to this list of what I will consider my sort of top 10. And what we're going to do is I'm going to go through them. We'll talk about them. Some of them I might show you examples. If you have questions as we go, feel free to ask them in chat. And let's get started. So the first one is basically do some reading. Like, this top part is around getting yourself the basic education of how does Docker work? What is basic security in Docker? How does Docker even, protect your container, that sort of stuff. And I have basically a production talk you can watch here. We're not going to watch that now, but I do have a link here to the Docker security guide. Now, what's interesting about the Docker security guide here is that it's really just about how does Docker security work, or how does Docker itself work. And there's way better videos in my course. I put links in there to other reference videos that are an entire hour about the underpinnings of Docker. But the two main things you need to care about are kernel namespaces and C groups. And namespaces, they go through a nice overview of how this stuff works. The summary here is there's two main features in Linux that allow Docker to even be possible. Kernel namespaces is a way for the kernel to take an application or a set of applications and namespace them. Namespace is essentially limiting their view, their access to any resources or what they see, whether that's networking, other programs in memory, or files on disk. It limits that scope per program. And so it can be for each individual program, and we know those as containers now, because namespaces isn't specific to Docker. It was around a lot longer than Docker has been. It's been actually around as a concept in different Unix distributions for over a decade. We might have heard this in Solaris jails or other types of technologies that essentially made you think that you were on your own server, but really you were contained inside a server with many other people and many other apps, right? We've done that a lot in Linux and hosting platforms. So namespaces is that feature. It gives your container its own NIC. It's a virtual NIC just for that container. And it gives it its own file space where it doesn't see the rest of the file system, and it doesn't let it see other programs running outside of that container. So it's about its access and view, right? That's namespaces. And that just works out of the box. That's how Docker makes a container run without seeing everything else on the system. The other big thing is control groups, or we call them C groups for short. And control groups are mostly about limiting resource usage. So you can tell a container it only has access to 1 gig of RAM, 1 CPU, that sort of stuff. It also allows for some metrics where you can measure things around that stuff, but it's really mostly about limiting your container. Now, remember, your containers by default can have access to all resources in terms of they can eat up all the file space, they can take all the CPUs, and they can eat up all the memory. That's just a standard container, but you can set options in Docker Run or in Swarm or Kubernetes. Any of those things have the ability for you to control resources. So, but it's just not by default, right? By default, any container gets everything. So when you're going into production, this is definitely on your to-do list. I wouldn't say control groups are necessarily a security feature, except for a particular application taking up everything that it shouldn't, and then it makes other things not be able to run, right? So that's not, I don't look at that as direct security. I look at that as sort of semi-related to security, where someone could technically do a denial of service by letting your app eat up all the resources on your server. So, you know, that kind of thing. So those are the basics. Once you understand the basics, there's a couple of good blog articles here on different types of security tools out there. And there's tons of tools, right? I'm not going to mention all of them today. Obviously, there's lots of stuff out there. But a lot of them are complicated and take projects. You have to implement them or buy them and then dedicate servers for them, right? Big products around auditing or making sure you pass certain credentials like a PCI credit card security or government regulation security, that kind of stuff. But that's not what I'm focused on here. This is about stuff we can all use that's free or almost free. And yeah. All right, let's look at the questions real quick before I get into it. What do you think about distroless images? Is it a good trade-off between size and security? So I would say if you can do distroless images, and what we mean by this, the term is in flux. I feel like distroless images is complicated. I feel like just saying scratch images might be an easier way to say it, but it is correct to say distroless image, meaning there's no base package system. There's no apt, there's no yum, there's not all those different commands that you would assume are in a container if you use one of the official images. The thing is distroless images aren't very common because of two reasons. One, most programs need all that stuff in order to work. They need apt package dependencies. They need their own, they need open SSL libraries. They need all sorts of stuff in addition to the program that's in there, right? That's most applications today. Golang, C, some other languages can build single binaries that basically have everything they need to run other than the kernel. So those things are technically able to remove everything below it. All of the layers in your image could go away. I don't see them a lot in the wild yet because I don't work with, Google and Netflix and huge teams of people that are super professional at this. So the two reasons here is, one, you have to have a language that supports it, and you have to have a team that understands how to build these properly. And then you have to really be good at troubleshooting and how containers and namespaces work. Because the minute that distroless image runs in a container and you have a problem, you can't even shell into it. There's no shell. You can't get into it. You can't look at it. So now your tooling is limited, and you have to start looking at other ways to connect your tooling into those containers. That exists. There are those things out there that will do that for you. But it largely depends on your skill set in terms of how you deal with namespaces. How can you jump in as a sidecar into a running container in its namespace from the command line without using Docker? Those are the kind of problems that creep up when you're dealing with troubleshooting or system monitoring and maintenance when you have distroless images. So for everyone that I work with that's starting out with containers, their first couple of projects in containers, I don't mention this stuff because size is just size. You can always add more disk space to a server, right? No reason to make a whole team run around learning all sorts of new tooling and stuff just so that you can have less disk space use on a server. So I personally don't care about size. Now, security is a theoretical thing. In theory, all those things getting removed from a container image might make it more secure. But let's talk about out in the wild, though. How many opportunities does someone have to mess around with other tooling in your container outside of your app? Let's say that curl has a vulnerability in it, but your app doesn't use curl. It just happens to be in the image. How is someone going to get access to that, right? They're going to have to break through your app. So your app has to have an exploit. And then in theory, they could run the curl command in the container, right? So that's really what this distro list stuff is about, is the theoretical security bonuses of not including other applications. The reality is, though, once you build a static binary, you're already including a lot of those libraries that could be vulnerable, like OpenSSL, which is a common way to connect applications with SSL security, right? Well, if that has a vulnerability and you statically build it into your app, it's still there. It's just not a separate file on the container. It's in your app in a single binary. And in fact, it actually makes it harder to security scan that because now every scanner that I know of won't catch that OpenSSL binary if it's built in. So a lot of this stuff is theoretical, and I don't tend to push teams toward theoretical security features. I look more at look what's happening in the wild, right? Docker daemons are getting exposed. Kubernetes doesn't have proper authentication, so it gets exposed. Those are the real problems that I see. Is the things that focus on are the things that we keep hearing about in the news that people are getting hacked with, right? This kind of stuff with theoretical security and removing files from images, that's just more in the theoretical realm. It's not a reason not to do it, but just like this list, everything in this list I would do first before I would start going down that road of hard stuff. And I do consider distroless images relatively hard, unless you're already a Go programmer and already your whole team is really good at namespaces and Docker commands and stuff like that. And I don't just mean regular Docker commands. I mean complicated stuff that helps you troubleshoot containers that don't have shells in them, for example. So it's a great question. It comes up all the time. Everyone asks me about it when we have security discussions because it's a popular topic, but it's not even in my top 10. So hope that helps. Let's see. Biker. I use Docker secrets for my passwords, but this just creates a RAM file in the container. If someone hacked into the container, they could see the file just like my application does. Yes and no. Okay, we'll keep talking. Is there any better way to do this? Encrypt the content of the secret and then decrypt inside the application in a way a hacker couldn't figure out. So the reality here is that your application has to have its secret somewhere, and they're going to be unencrypted in memory, right? Everything I know that is decrypting encrypted stuff, it's decrypting it into memory. So if a hacker has root in your container, then it's going to be able to get that. If they're savvy enough, they're going to be able to get that stuff, right? So the first step there is don't run your application as root in the container. Then they can't muck around with anything outside the application. They can't run other system utilities in the container that might be able to read all the memory, right? The second thing is really the most secure way that I think we've seen is something like Vault and one-time passwords, where they get created, they're used by your app, and then they're thrown away and no longer good. But the reality is most people aren't ready for that. Most people's apps can't handle that. You can't rotate a Twitter API key every 5 minutes for every app that launches, right? Stuff like this. So the next best thing is preventing that file from ever being permanently on disk. And a Kubernetes security and Docker security, those, secrets, Kubernetes secrets and Swarm secrets are some of the best ways I've ever seen to come up with a way to store passwords on a fake file in RAM, and you can set those permissions so that they're only readable by your app. Right? So if someone gets in somehow with a different user, not that you'd have a different user necessarily in the container, but you can lock those down so that they're read-only, that they're only readable by the user, that's your app, that's the kind of stuff, right? So that is really it. The only thing that I've seen better still stores them in memory, still stores them unencrypted. It just doesn't store them locally. So you'd have to use a remote API like Vault, HashiCorp's Vault, or some other system that delivers one-time passwords. But again, those things would have to be built across your whole system. You'd have to design the whole thing. And that's a lot of work, right? Whereas using the secrets in Kubernetes and Swarm, you can typically get that stuff done in the same day, right? You can implement that for just about any app, even if it has to set them as environment variables, because older applications require things in environment variables. So you can have them in secrets and then at runtime, have those secrets dumped into environment variables if you have to. But I'd say 99% of the time, my consulting clients, they're dealing with legacy applications. When I say legacy, I really mean everything before containers, which is most applications, right? We've spent 30 years creating applications without containers before we had them. So we have a lot of regular stuff. And so most teams are just looking how to get things into containers and store them encrypted on disk, right? If they're on disk, they're encrypted. And Kubernetes and Swarm can both do that. So I think if you're using secrets, you're already better than 99% of the people I see, because very few people are using orchestration and also using secrets. It's a very, very small bunch of people. So yeah, I think you're pretty good there. All right. Before we go to some other questions, I'm going to start down the list. All right. First up is just running in Docker. And this requires you to sort of create an argument, because this is probably, if you're having a barrier with this, right, just using Docker, number one, if you can't get this done, well, one, you're probably not watching my show, but that probably means you have a security team or management that has read something somewhere that there's, security around Docker. The latest thing was, if you scroll down to the bottom of this issue, is that there are images out there now, and, it's not news to anyone that if you run random software off the internet without checking it first, you may end up with a virus. And basically, people are creating images on Docker Hub with cryptocurrency or cryptojacking tools inside them that will essentially run, you think you're running this other piece of software, but you're really running something nefarious for the hackers. Well, this is not new, and Docker doesn't necessarily make this any easier than anything else. We all know the rules. Don't run random images, just like you wouldn't run random code on your server. You don't download random stuff, from the internet. So don't do that in images. Only run official images, or those that you absolutely trust, meaning the vendor's staking their relationship with you on that image, and you don't necessarily have to scan the image with every line of code, but you're using reputable products from reputable companies, right? So if you're doing that, this whole recent news thing that made a bunch of headlines doesn't even matter. Like it wasn't a vulnerability in Docker. It was people configuring Docker by disabling security that was in and out of the box, and then going and downloading random software and images. So of course they're going to have problems, right? I think the real news there is that hackers are getting more sophisticated. They know more of us are running containers, so they will start putting viruses in container images, right? And Docker Hub does not scan every image. It only scans for security issues in official images. It's not a feature of Docker Hub anymore. Well, they never did it for everyone, because there's 30 million images, but you could pay them in the past. And you can't pay them anymore for that. All right. So step one is just using Docker. In case you didn't know, when you use Docker out of the box, it is already hardening the application in there. One, that application can't see the rest of what's running on the system. So it can't even access the rest of the stuff running. It's just only what's in that container, right? The real big thing there, though, is that a container in Docker enables a bunch of Linux security features that normally, if you just run apps on the host, aren't enabled by default. And that includes seccomp, apparmor, SE Linux, and kernel capabilities. So those 4 things are all inside of Docker and enabled by default, assuming your host supports them, because not every Linux distribution supports every security tool. But those 4 things, especially apparmor, seccomp, and Linux capabilities, are enabled out of the box for every container you run, which is why sometimes certain applications, you have to run it like -- privilege. You kind of have to run it with the privilege mode. That's because those defaults are conflicting with whatever that app wants to do, because those defaults that Docker sets are common for most applications to work correctly. And so Docker basically went through a whole bunch of tools way back in the day, scanned a whole bunch of common open source software, and figured out what they all tend to have in common in terms of rights, in terms of permissions on the host. And they took the rest of them, hundreds of other things that the regular applications can have access to, and they took them away. And that resulted in Docker having a very secure default profile. So if you just run Nginx on a host, it has access to everything in the kernel that user has access to, which is usually most of everything. But if you run it in a container, it locks so much of that down that it's automatically more secure out of the box, even if you didn't customize any of those things. So that's my argument for why Docker for security. Just do it, and you automatically get all these things enabled. Most people don't know about how to use apparmor or how to use seccomp or SE Linux, how to customize those things for each application. But Docker did, and that's what they do out of the box. All right. Number 2, scan your host for proper Docker config. So here's a really great tool, free, called Docker Bench. Made by Docker, this tool will scan your host. Basically, you run it on the host that has Docker installed. And the output kind of looks like this. It'll give you blues, greens, yellows, reds, all that stuff. And it's a configuration checker. It's not scanning for viruses or vulnerabilities or anything like that. It's scanning your configuration. Did Docker get installed properly? Does Docker have all the right permissions that it needs? Does it have all the right kernel capabilities to perform proper functionality, especially around security? So, for example, if your system doesn't have SE Linux enabled or apparmor enabled or installed, and Docker wants to use those things, it will note that stuff here. And so before I decide on a proper configuration for servers that are going to go even just for testing, not just production, I'll just run this little shell script. And you can run it straight from the website. They give you instructions here on how to run it. And it'll dump out a bunch of stuff. Now, it's never going to all be green like most security tools. It's still going to give you certain things. And you have to look through those and decide, is that okay? And it just kind of makes you a smarter admin, makes you aware of certain limitations or problems with your system. And you might find out that for a certain Linux distribution, that's not going to work at all. That particular thing is just going to have to be insecure or not a feature, that kind of stuff, right? So it's good education, and it uses a thing called the CIS Docker benchmark, which is sort of a industry standard for how to make sure the security of a host is properly set up for Docker. And it's great. It's an easy utility to run. I would run it, like if you're going to be building servers with Ansible or Puppet or whatever you're using to build servers, once you've got that configuration, I would deploy your servers into a mock setup, running your configuration tool. And then I would run Docker Bench against it. And you would get a bunch of output, and you could go through those one by one, deciding, am I okay with this? Can I fix it? What do I got to do? Should I ignore it? That kind of stuff. All right, so that's an easy one, right? And that's about configuration. That has nothing to do with your app. It's just about Docker itself and the host it's on. All right, next one up. This is a big one. Don't run your apps as root in the container if you can avoid it. And if I do this real quick on a little demo here. All right, so I've got Docker running. At least I should. All right. And if I just run, if I just run Nginx, right, and I do a Docker top on that container, what do we see here? Inside the container, Nginx started a process at root, and then it created a new process as a non-root user. See how that user is 101? So this is common of a lot of daemon-based programs like MySQL, Postgres, Nginx. A lot of them that aren't programming languages will automatically do this. So this is safe. What this is doing is this is allowing Nginx to spawn off worker processes that don't run as root to do the majority of the work. So they have one master process that runs as root, but that's not what's accepting connections and doing majority of the work. Most of that's in these worker processes, and they run as a normal user, which means if there is a vulnerability in Nginx, chances are when incoming connections are coming in and someone's trying to exploit the Nginx HTTP protocol, it's going to be locked or jailed into this user at most of the time, unless there's a serious vulnerability that's up here. So down here, and then they're limited to what they can do, right? Even if they were to take over that process somehow, they're still limited as the user. So this is okay. This is still not running as true root inside the container. What I really am talking about is if you were to run a Python app or a Node app or something like that where it's a programming language, then that's going to be something that defaults to root, because the programming language in the container doesn't know how your program works. It doesn't know what you want it to do. So it's going to do root by default. And that's more about application compatibility. We might say that we want this to be secure by default, but Docker chose for all these official containers to really run as root for the programming languages. So let's go check that out. Oops, not that one. Firefox. So if we go, let's say, over to Hub, and let's just do Node. This is common of most languages, but I'm just going to pick Node as an example. So inside Node, if I go into one of the Docker files here, then I search for user, you'll notice that I don't actually find anything. It's only this user add here. But you'll notice that it does this, right? It's technically adding a group called Node, and it's adding a user called Node. But if you search the rest of this file, you realize that it never changes to that user with the stanza user, right? It doesn't. You should see user Node in there somewhere as a line. They don't do that because that's your job. So what you should be doing in your down-level Docker file, so any Docker file you're creating off of these official images for programming languages, you should be taking advantage of the users they're creating for you. And if they're not creating those users, you can create one yourself the same way. You can just steal this little 2-line thing and change to whatever the user you want it to be. If it's for Python, you might just call it Python user, whatever. So if you're doing that, then the applications you run will not run as root in the container. By default, if you just run any standard Node app, it will use the root user in a container. Now, why is this so important? Well, 2 things. One, if someone is able to break through your application and hack into your application and gain access to the file system, if that application is root, then in the container, they can do whatever they want in the container, right? They can write files to the file system, they can install more programs in that container, they can run whatever they want in that container. So we really don't want them to do that. We'd rather them be very limited. So if your applications support it, do this. You basically make sure that you have the user available. And then I have an example from DockerCon over here. At DockerCon, I had a whole talk on Node.js, and one of the topics was on the user. So let me see if I can find that. All right, see what I did here? This is a pretty simple file. I'm gonna link this and put it in this Docker file. So in this Docker file, I didn't create a user because the Node image already created it for me. I'm just changing the user to user Node. And then I'm installing my packages with these 2 lines, and then later I'm going to run it. Now you'll notice that I have to start using the chown option in my copy commands to make sure that my files are now the same user as the user my program will run as, or otherwise there could be problems, right? My application probably, if it can't read the files, then it can't run it, right? So I need to change those permissions, and I can do that with a 1-liner on a copy command. You'll also see up here that I'm creating the directory and chowning it as well, so that whenever the app is copied in, I just want to make sure, extra sure that the permissions are there so that it can write. Because the minute I change this user, then this copy command, or specifically this run command, will run as that user. And if it doesn't have permissions to write to the directories, then it's also going to fail. So the reason that Docker doesn't do this for you is because they know that your things will probably break. So you need to take these extra steps, but it's not that hard. It's really not. You can probably do all of this testing in a day, and then you'll want to run your systems, through full CI and full testing on your servers, because sometimes, and PHP is one of the ones that's bad at this, PHP likes to run a bunch of log files and do a bunch of writing to disk. Really anything that's allowing user uploads will write to disk. And so you got to make sure those permissions are correct so that when people are writing files, like let's say they're running a WordPress blog, that WordPress blog will be writing to disk when users upload images into their blog. And you want to make sure those permissions are going to work. So you're going to have to definitely do some testing. But once you've done that, now your application will not run as root. So it can't have full control in the container. The other reason you want to do this is if there's a vulnerability in Linux, which is rare, or Docker, which is also very rare, then there's less likelihood that they're going to break out of this container. And that's only happened, one time that I'm very aware of, and I actually documented a little bit of it down here. Dirty Cow. Dirty Cow was a vulnerability in Linux that allowed you to get out of a container, right? And the changing of your user right here wouldn't necessarily solve the entire problem, but it certainly didn't hurt that problem. Other vulnerabilities it would probably protect against. But this is a best practice. I think that if you have a security team, they're kind of going to insist that you don't run things as root. So you would do that. All right. We're down to number 4. All right, let me check the questions real quick. How would you deploy an app to a prod production swarm cluster from CI pipeline in the most secure way possible? Would you install CI runner there, or would you connect from build environment or use some specific tool? I would just I would not install a CI runner on any server. I would simply have my CI tools running the Docker command line, and it can connect to a remote engine over SSH. And that's how I see most systems doing it. Unless you have some higher level tool, maybe you have Ansible controlling Docker, and then maybe your CI would then control Ansible, which would control Docker. I mean, that's a complicated setup. A simpler setup, the CI just runs the Docker command line, and that Docker command line will use SSH to connect. And I see if we have... I talk about this in this same blog post. I don't talk about CI specifically, but let's see if I have a link. So there's a link here where it takes you to a blog post, remotely control Docker engine through SSH. So this allows the Docker command line to tunnel itself through SSH automatically. It's a feature that came out about a year ago, and I have... In this channel, I have other videos. If you just search SSH in this channel, you'll find videos on how to do that. And I would do that in my CI. So all my CI has to do is have SSH keys to the servers, and then it can deploy that way. So that's what I would do. It uses common security tools. It's not fancy, because fancy in security is usually bad. A complicated security is not necessarily the best security. I always focus on simple security tools first before I start going out after whiz-bang automation tools like that. So I would say keep it simple, Docker command line SSH. Good question. Yep. All right, some questions there I'll save for later. Back to the list. All right, so we know not to run as root in the container, but outside the container, the root in the container, by the way, doesn't have a direct access to anything on the host, right? Just because you're root in a container, you're still jailed in there. But if you want to take that next level, where if the user, even as root in the container, wants to break out to the host, because there's a kernel vulnerability like we talked about, like Dirty Cow, or another vulnerability in Docker or something, then the next step you do here is enabling user namespaces, which is not enabled by default. And I have a link here that takes you to a blog article that talks all about it. Basically, it's a per host setting that you set in the Docker configuration, the Docker JSON. And it tells Docker that anytime it creates a new container, to run that container as a non-root user on the host. So basically, there's a couple of programs there, containerd and runc, which are other programs that Docker uses to start your container. And by default, those do run as root. A feature that Docker has is to enable user namespaces, which essentially means as the Docker creates these containers, it won't spawn them off as a subprocess that's running as root like Docker does. It will spawn them as a high-numbered user, a sort of not necessarily a random user, but a high-level user. And that means if that container ever has any security vulnerabilities where the user is able to escape the container, there's still only going to be a user on the host, because they're going to be acting as the user that the process that's running that container is using, the runc, essentially. The runc program is what launches that container, and it will be running as a high-numbered user, not root. And that user doesn't really have any privileges outside that container. So that feature is a per host setting, not a per container setting, and not everything works under user namespaces. And you're going to have to try and practice. You're going to have to enable it on some servers, try your applications on that server, see if they work. And if they don't, you're going to have to segment your architecture. So whenever I implement user namespaces in a cluster, we typically have specific worker nodes that have user namespaces enabled, and that's where those programs run that can support it, that work with it. Then everything else has to run on regular Docker servers somewhere else. So that's kind of how we segment it out. We segment it into two classes of servers. And that, like if you're running a DMZ, that's what I would do is I'd enable in the DMZ all the user namespaces on all the servers, and then the containers that run there would have to support user namespaces. Now, you can't go look at applications and find out if they support user namespaces. User namespaces is not necessarily a Docker-specific feature. It essentially means your container's running in a namespace, and now the application running that container is also locked down a little bit. And not everything can support that. You're going to just have to practice, or maybe do some research to see if other people have been able to get it to work for common things like MySQL and stuff like that. But obviously for your own programs that you're developing, you're just going to have to test them to see if they'll work. I'd say most programs in common languages that I run, they work just fine in user namespaces. The real issue with user namespaces is when you have an application that needs to write to volumes or to bind mounts, that maybe you've got user file uploads and you're sharing those across many different containers. That's where user namespaces isn't impossible. It just gets a little tricky, because the files that are now written to disk on the host are now being written as a different user, because that process on the host that's managing the container is a different user. So you'll see different user IDs on those files, and you're just going to have to deal with that. There's, it's standard Linux permissions at that point, and you just have to automate and solve those problems in various Linux standard ways. It's not even really a Docker problem at that point. It's just a permissions problem on the host. So, all right. The next up, code repo scanning. So this is not even Docker specific, but there are tools out there, and Snyk is one of them. Snyk will scan your code dependencies inside of repos. Now, if you have open source, if you're developing an open source, they will do a lot of this stuff for free. And they will scan your GitHub repo, your Bitbucket repo, and look at the dependencies. And I get reports every week from them on my open source repos and any vulnerabilities they found. Now, nowadays, GitHub does a lot of this themselves for free as well. Snyk has been around longer and been doing it longer, so I kind of have both. I have GitHub sending me emails, and I have Snyk. Now, you can pay Snyk to scan stuff. They also have more features now where they're doing images as well and other things, not just code repos. But that's one line, is scan your repos early on in the process. Don't wait for you to build images and then have things in CI, but in testing where you're scanning. Scan as early as possible. This is kind of one of the core tenets of something called shift left security. So if you imagine a Kanban board where all your work is on the left and your output is on the right, the shift left security movement, if you just kind of search around for shift left security, is all about shifting the responsibility of security earlier and earlier in your development workflow. And so one way to do that is to have these automated scanners scanning your code dependencies inside your Git repos before you ever even get to the stage of running stuff on servers, right? So I would do that. Not specifically a Docker thing, but I would do that. The next step is image scanning itself, which is very similar to that. But we get more features here. We aren't just scanning your code dependencies. We can scan the container itself, the image, right? We can scan all the dependencies there that are not just like your npm packages or your, Python packages, or you're now scanning yum packages and APK or apt or these kind of package managers for the OS. That's what I mean by an image scanner, because it can scan those as well as your code dependencies. So there's a lot of tools here. A very popular set of them have been around a while, but a couple of new ones have shown up that I want to talk to you about. The first one here is Trivy, and I just learned about this month, actually in October. And Trivy is built by Aqua Security, who's the same company who builds Microscanner. So Microscanner was one of the tools, along with a lot of other ones. Anchor is another popular one. These are all open source tools that scan your image for CVE vulnerabilities. So the CVE is that database of all the open source vulnerabilities that we've all hear about in the news. And it's from MITRE, a company that manages that database. And this is a community thing, right? Anytime someone finds a vulnerability in software, they put it in and it gets a CVE number. I think it's common vulnerability and exploits or something like that. I can't remember exactly what CVE stands for. I'm sure one of you will tell me in chat. But CVE gets a number, right? And we see a number assigned to that known bug in the community. And a CVE scanner will scan your images for that vulnerability. Now, once you get into the implementation of these, there's all sorts of minutia, like does the scanner you have need to run in the Docker image during build time, or does it scan an image that's already built? Does that scanner support your base distribution? Does it support Red Hat? Does it support Alpine? Any sort of other distribution images that you've chosen to use, will it support those? Does it also support your package manager for your app, like npm or pip or one of the other dozens of package managers out there, right? Does it support those as well? So Microscanner didn't do all of that. It did some of it, but like a lot of these other tools in the ecosystem, they didn't do it all. And right now, this one from Aqua Security called Trivy, get all the way to the top of this thing. So Trivy is claiming they're the most complete open source free scanner out there. And you can actually go to this, that's why I was, yeah. So down here, you'll see what they support. And you'll notice that they support all these based images. And then if you actually go down, there's a comparison showing them comparing to all the other tools, or at least the popular open source versions of these tools. There's definitely more tools than this. But there's lots of choices you have to make here. One choice is, where do I want to scan? Do I want my image repository to scan them itself, like Docker Enterprise DTR does, where you have a registry holding your images, and that registry runs scans on the images in the registry itself, all in one go? Quay does this as well. Quay is a cloud hosting image repository, and it will also scan, right? But each one of these scanners doesn't always scan all image types and all app dependencies. So it's pretty cool here that they show basically the X means they don't do it. The 0 or the O there, the circle, means they do it. And then I think the double O here means the best. And the triangle means there's issues, there's concerns there. And so they're kind of claiming that Trivy, which they bought this year, I believe, Trivy does it all. It does OS packages, application dependencies. They claim it's easy to use. They claim it's more accurate. And if you start reading into this, you realize that one of the big issues that I keep talking about is that Alpine's base image doesn't work with almost all these scanners. It just doesn't have the vulnerability database connected to it properly so that when you run these scanners, it detects vulnerabilities in Alpine. So Trivy claims that they fixed that by a new method that they're implementing, and we'll see if other people implement that as well. So they claim to be the most complete. A lot of my Docker Captain friends are all saying they're using it and using it great. But one of the other decisions besides which scanner is where will you scan? I like to scan during image build. I'd rather scan during the CI automated image build than scan it later after the image is built. That's just me. You might even have different systems that scan at different times just to be safe, right? Just to be certain. You might have systems that scan on the servers that are running in production, depending on your environment. That's not very common, but if you're in a super secure environment that you want to scan things running live, you can certainly do that with some of these tools. But a demo that I often give is about Microscanner. And essentially, all you have to do in Microscanner, as well as this other tool, is you can, in Microscanner, you can add it into your Dockerfile. And I believe the Trivy app, you scan after the image is built. So if you're super paranoid, you might just use Microscanner inside your Docker image, and then you might run something like Trivy after the fact on the images before they're sent up to the registry. You know, you can always download them later, but I like to know that my image is vulnerability free before I send it up. So that's what you might do there. Now, I want to just tell you a warning. You're probably not going to have you're probably going to have any images, or maybe just a few images that have zero vulnerabilities across the board. And that's just due to the nature of open source. Typically, if you scan any image, typically if you scan any image out there, it's going to have vulnerabilities. And it's your job to work with your security team on what's acceptable, not we can never have vulnerabilities. Because certain vulnerabilities may not even apply to you. Just because they're in your image doesn't mean that they're automatically going to be a problem, right? So you're going to have to do some work. I think what I would suggest is implementing these now, but turning off the sort of failure of it and say continue on failure here, which means all I'm going to do is warn you that there's vulnerabilities. I'm not going to stop the build just because there's a vulnerability. This is key because if you start implementing all these tools automatically, they will fail the process. They'll fail your CI or they'll fail your builds if you just turn them on. So you want to make sure that you have them in sort of audit only mode where they don't fail on finding a vulnerability. That way you can at least learn what the vulnerabilities are before you start it, before you go hardcore, right? Before you go hardcore. All right. So moving on from those, we have runtime bad behavior. So I won't really talk a lot about this one, but this is the newest one on my list. The sysdig Falco is a tool that there are other similar tools, but none that I've seen that are as easy or as designed for containers as Falco. And Falco essentially takes a common little list of bad behaviors, or what I would say, behaviors that are suspect, right? Things that shouldn't necessarily be happening a lot, like execing into a running container on a production server, or copying files into those containers on running servers, or bind mounting sensitive data from the host operating system into the container itself, right? And they'll show you a little example here on exactly what you do. They're basically running Falco agents on every server and then doing certain behaviors in containers that might be suspicious. And the goal of Falco is to audit and log those behaviors for you to basically track any bad behavior and alert on those logs if you need to. And you can see them here running some certain things and seeing what the logs are outputting. The coolest part about this is that it comes with a default set, because a lot of us don't know all the bad behaviors. Like, we don't know everything you could possibly do if you're a bad actor. So the nice thing about Falco is it does come with a default list, and then you can add more rules on your own in your applications. You can make custom lists, add them to Falco when it runs. So that's a free open source tool that I would definitely say is getting more advanced, right? As you can see, this list, as we go down the list, getting more advanced. But I think that's something that's worth adding to your production servers, even if you don't monitor those logs constantly and you don't alert on them, just having those logs so that when you have something that's problematic, you can go back and see if there was any behavior and what that behavior was to sort of trace your steps, right? So I definitely would put that in your toolkit. Next up is content trust. I don't really have a demo or a way to show content trust because it's a set of tools, Docker provides a lot of them, on making sure that everything in your pipeline, from code signing in your Git repos all the way to making sure in production that only images signed by your team are allowed to run on servers, that whole process is known as content trust. And it's a pipeline of trust. It's a pipeline of signing different parts of the tooling, your images, your code, to ensure that nothing runs in Docker on your servers unless you specifically allowed it through signing. Okay? So that's a project. It's definitely a project, right? We're getting down to the bottom of this list. So when you start talking about secure development and secure deployments, this is one of those more advanced features because it requires your developers to be involved, your security team. It requires code signing and image signing, which Docker's tooling definitely makes easier, but they're not going to do it all for you. All right, you're going to have to implement these things in your teams. Next up is something that takes a lot of work and may not give you a lot of advantages. And that is taking all those default profiles that I talked about earlier and taking all those default profiles of apparmor, SE Linux, seccomp, and Linux capabilities, put that in quotes because that's actually a feature in the kernel. And there's like 300 capabilities or something. And Docker will take certain ones and remove them, but you can change those. You can customize those on the fly. You can actually lock down more, or you can open up Docker depending on your needs. And if you learn about your specific applications, if you dive in deep, you can learn about how to lock these down more. You might even find that some of your applications that you buy or get from open source, like Nginx, they might have custom templates for these tools that you can download and apply specifically when you run that image. Because Docker itself doesn't know what's running in your container. It doesn't know that you're running MySQL, right? So it can't apply a MySQL specific policy. But you might be able to find one. You might be able to create a better one that's a little bit more secure. That's pretty advanced. You have to be pretty knowledgeable about systems, internals, and how that all works. But Docker supports it all. And this is a per container feature, which means you can change it for each container you're running depending on your requirements. So check that out. Your security team will love you for that. If you can get this stuff implemented and not break anything, that's the key. Don't break anything. Your security team will be big fans of that. And then the last one here is Docker rootless, which is a relatively new feature in the last year that allows you to run the Docker daemon, the Docker engine itself, without root. And this doesn't work in every case. The big gotcha here is that it doesn't allow custom networking. So you can't create all these fancy bridge networks without having root. In Linux, you need root to mess around with networking, essentially. So as long as you don't need that, if you can get away, maybe this is something you do in CI, and you just need the CI worker user, maybe it's called Jenkins, right? You have a Jenkins user, and you need it to run certain things, then you can set up that CI to start the Docker daemon inside a user's home directory and then run all of its stuff there. And then it can stop Docker and exit the process, and you never needed root on that machine. I don't see a lot of potential for this in production, but it is possible. If you don't need any of the networking capabilities of Docker, or you found another way, essentially you can run other commands that create these networks manually, and you don't depend on Docker for that. So if you can deal with that stuff, then there might be a way for you to have no root at all, even with the Docker daemon. Now, this is still running as a systemd process, right? This still isn't running in the background. It's not running in the foreground. But Docker's got a nice script. It's here at git.docker.com/rootless. So you can essentially just run that script. And if your system is compatible, it will essentially run Docker as that user. And it'll download it, configure it. And then you can watch a DockerCon session on it. In fact, on this channel earlier this summer, I had other Docker captains on giving demos about how rootless works. So also check that out on this channel. And that's my top 10. Anything after that starts to get into paid products or really application-specific tools that aren't necessary in the broad sense of everybody's security. So I would go down this checklist as you implement your tooling. And this is really production specific, right? This isn't a lot of stuff that you'd be running locally for development. This is about production servers. So I hope you like it. Let's take a last look at some of the questions. Let's see. SolarWinds tells us their container monitoring we have to run in privilege mode. How do I request that when using Swarm with stack YAML? How is this different from running and just running in root? And if I move to non-root containers, does this kill privilege mode? So yes, if you are, the privilege mode essentially runs everything in the container with complete full root access on the host operating system. It's the last ditch effort. If SolarWinds says they're needing to run as privilege mode, one, I doubt that. They just don't know what they're doing. Privilege mode is the escape hatch for when you don't know the capabilities that you need to enable for your containers. Now, we all do it. We're all guilty of it. But if you have a product company making a product and they don't know what capabilities they specifically need and don't need for their tooling, then they're just going to basically say, oh, it works for privilege mode, so just do that. It doesn't mean you don't implement their tool. It's just now you have to decide, do I really want this tool? Or is my security team going to flag it and basically deny me using this tool because it's going to run with complete root privileges on the host? Now, some might argue that monitoring tools need a lot of permissions in order to accurately get a lot of the system monitoring internals of applications on a host operating system. So it may not be that uncommon if we scan the landscape to find different tools needing root permissions. But it's up to you. That's kind of an evaluation that you have to decide, am I willing to use this tool or can I go find another tool that doesn't need to run as root? Because there's definitely tools out there, but SolarWinds might be doing really deep stuff. It might be doing deep inspection in the kernel itself of behaviors of applications. And so you have to decide. It's a yin or yang. It's up to you, really. It's not necessarily bad, but I would say privilege mode just tells me that they maybe don't know exactly what privileges they need because they're probably not using all 300 privileges of the operating system. There's actually one capability inside the Linux kernel known as sysadmin, and that particular capability essentially gives you everything. It gives you complete control over the whole system, if I remember it correctly. And so if they said, well, we just need this one capability, it's essentially the same in my mind as privilege mode. I could be wrong on that, but there are a few of those capabilities in the kernel that basically give you God rights. So either way, privilege mode might just be absolutely what they have to use. If they're running as root on the host, they're essentially getting the same thing as privilege mode. So you might have been running all your tools and monitoring tools as root anyway. So you can't get more permissions in root. So this is them running in container and just saying, hey, when we run in container, we basically need complete root access on the host operating system. Sorry. And that's just a feature of their tool. So yeah, it doesn't mean that you say no. It just, you have to weigh that against the pros and cons. Are there other tools that are just as good at getting what you need out of them that don't require full root on the host? Yeah. All right. Is there any additional security recommendations specific for Windows containers? So Windows containers, unfortunately, is a whole totally different thing because Windows containers don't have SE Linux or apparmor or seccomp or Linux capabilities. They're Windows specific. So it would honestly end up being largely a different list. Now, things that aren't related are things like scanning your images, things like scanning your code, right? So just using Docker would be on that list. So we'll look at the first one there. Scanning your host, well, there is, as far as I know, there is no Docker bench for Windows, so you couldn't do that. Running your apps and containers as root. So same thing in Windows. Run your apps as not the administrator user. So you would do that on Windows. User namespaces, I do not believe is a thing on Windows. Windows has, for about every single one of these kernel features, they don't have the same name. They have something else that's similar. So it wouldn't be called user namespaces. You could definitely do number 5, code scanning for Windows. You could scan Windows images, but a lot of scanners don't support Windows. So you're going to have to find a very specific image scanner that is designed for Windows dependencies, like .NET 3.5 vulnerabilities or, .NET Core 2.0 vulnerabilities, stuff like that. The next one, running bad behavior. This is only, as far as I know, this is only for Linux. I do not believe Falco works on Windows. Content trust is a general industry practice. It's not so specific for production containers, so you can definitely sign images and sign code on the Windows side. And then you would enable Docker. I'm not sure if the Docker engine has this feature, so you can click this link essentially and read about content trust and find out if Docker supports the engine features for that on Windows. These obviously would not apply because these are Linux specific. And then Docker rootless does not run on Windows as far as I know. You can't do that on Windows. So that's a really quick way to get through the Windows list. And that's a great question. I'm glad you asked about that one. So looks like we're at the end of questions. And this was a great list of questions. Thank you very much for them. And again, go through this list. You can get to it through bret.show/security-first. And at some point, I should probably make like a little PDF or something to download for people in the course, because it would be nice probably to have this common list of things. But I really appreciate you all watching, and I will see you on the next YouTube Live back here on YouTube. Ciao. Happy Halloween.